Good morning, Miss Monse. My name is Natalie, and today we'll be presenting our chemistry experiment about proteins. And our group is conformed by Alexa, Naomi Raudales, Dioselina Pacheco, and my person. The purpose of our practice was to observe how proteins behave over different conditions such as heat, pH, and enzymes, and to understand concepts like denaturation, coagulation, enzymatic activity, and protein stability. We divided the work into three stations. Naomi made station A, Alexa made station B, and at last, Dioselina made station C. I'm the one who is narrating the video, and I will be explaining you what did we did in each station. So let's begin with this. Station A, denaturation by heat and acid. In the first station, Naomi worked with milk. She heated about 250 milliliters of milk to approximately 50 to 60 Celsius and then added vinegar as it shows in the video. She observed the formation of white curds, which is casein, and a yellowish liquid called whey separated. The milk curdled well in our experiment. The evidence of denaturation and coagulation was a clear formation of solid curds from liquid milk. Whey appeared yellowish because it contains other soluble proteins and pigments left in solution after casein precipitated. This demonstrated that how changing the pH with acid disrupts the protein's tertiary structure, causing it to unfold and clump together. Station B, proteolytic enzymes in gelatin.
Station B, proteolytic enzymes using gelatin with juice fruit. For this experiment, we are using three materials: unflavored gelatin, pineapple juice, and meat seasoning. One of our first steps is going to be to microwave some water for the gelatin. And we pour the gelatin. Now that we have some glasses, one is it's labeled as fresh, processed, seasoning, and control. Now I'm gonna pour the gelatin mix on each one. Now I'm adding some pineapple juice to the fresh and proceed containers to see what could happen in the next minutes. Now I'm adding a sprinkle of seasoning, also known as meat tenderizer, to the gelatin mixture. And to the control container, we're not adding nothing. But now we will chill on the refrigerator for a couple of minutes to see what would happen. So, the key variable that explains the difference between fresh and processed fruit is the activity of proteolytic enzymes. In fresh fruit, enzymes like bromelain, pineapple, acetylcysteine, or kiwi, or papain meat tenderizer remain active and break down the protein structure of gelatin, preventing it from forming a solid gel. While in processed fruit, these enzymes have been inactivated by heat during the canning or pasteurization, allowing the gelatin to set normally. Processes work by cutting proteins into smaller fragments, which disrupts the stable protein network needed for gel formation. To verify that heat inactivates these enzymes, you could heat fresh fruit or its juice until it boils briefly, then add it to gelatin. If the gelatin sets properly afterward, it confirms that heating this is destroying that enzyme activity.
Station C, protein foams, beaten egg white.
Hi, my name is Serena and I'm going to be making Station C, beaten egg white. The things we're going to need are salt, lemon as acid, an egg white, and some containers.
Finally, Dioselina made foams with egg whites to observe protein stability in foams. First, she poured an egg white into a clean bowl. She beat it vigorously with a whisk for 2 to 3 minutes until a foam formed. Then, as you can see in the video. She divided the foam into 3 equal glasses labeled as no additive, salt, and acid. In the salt glass, she added a pinch of salt mixed gently. In the acid glass, she added half a teaspoon of lemon juice and mixed it gently as we will be watching in the video. And in the no additive glass, remain as it was. After this, she left all foams rest for 10 minutes and then measured their heights. Acid foam measured 5 millimeters, salt foam measured 8 millimeters, and no additive foam stayed at 1 centimeter, showing it was the most stable, as you can see in the video. So, in conclusion, this experiment allowed us to see how proteins respond to acid, enzymes, and additives. In Station A, acid caused milk proteins to denature and form curds. In Station B, enzymes in fresh fruit partially broke down gelatin, while heat inactivated enzymes in processed fruit allowed it to gel, as Alexa shows you. And in Station C, egg white proteins formed foams and stability was affected by additives. This practice helped us connect protein behavior with real-life examples in food, showing how environmental conditions affect protein structure and functions. Thank you so much for your attention and hope that you like our video.